But yeah, the empty. Shall we get started? What trading is going on? புரியல. சென்னை சில்ஸ் சரியுதா? அப்படியா? இது fully gone? இங்க இருக்கு. இந்த சைடு. இந்த சைடு. இங்க இருக்கா? இப்படி பார்த்தா அங்கே சென்னை சில்ஸ் அங்க தெரியும்டா. எதுடா? நீ அங்க போய் பாரு, பால்கனிக்கு போய் பாரு, அந்த பக்கம் தெரியும். நீ சுத்தி வர்றதுனால கன்ஃபியூஸ். சாரி, இந்த சைடு. திஸ் சைடு. எதுடா? நம்மளுக்கு அது பிரச்சனை இல்லை. இப்ப அங்க என்ன பிரச்சனை? இவன் ஒருத்தன்டா. நீ லீவ் எடுத்து தொலை. எவன் போக சொன்னான் டெய்லி? தூங்கிடு. சண்டே லீவுன்ற கேட்டகரிக்கு வந்துட்டான். எவ்வளவு இதெல்லாம் முடிஞ்சது இல்லடா. Any doubts in what we discussed the previous class? எல்லாம் புரிஞ்சதா? All clear? Okay. Let's just revise the concepts that we discussed in the previous class. So what are the two concepts that we saw? One is when you connect an AC source across a resistor, and second case is when you connect it across a capacitor, right? So whenever you connect it across a passive element, what are the steps you need to follow? First, you need to understand what is the input you give. So you give an EMF. For the given EMF, what is going to be the output? You need to find it in terms of current, right? So for a resistor, what is the relation you will get? If E is equal to E naught sine omega t, what will be the value of I? I will be equal to I naught sine omega t. That clearly indicates that they both are in the same phase, right? So when they are in the same phase, then how are we going to draw the phasor diagram? It is going to look like this, right? So the phasor diagram is going to be in such a way that the EMF and the current, they both are going to be along the same line. So 1 minute, am I sharing the screen? Yeah. Yes. So the EMF and current are going to be along the same line. So what does that indicate? That they both are at the same phase. They both are in the same phase. Next is when you do the graphical representation, how is it going to be represented? So when you draw the graph, right? So EMF and current will be along the same phase, meaning wherever EMF is reaching the peak, current will also reach the peak at the same point. But the only thing is their magnitudes will be different. Did you understand? So EMF will have a greater magnitude, current will have a lesser magnitude, but both will attain the maxima and the minima at the same instant. Right. So when you draw a graph, what should be taken on the y-axis? E comma I should be taken on y-axis, and what should be taken on x-axis? Omega t. So when you do this is how the graph is going to look like. Right. We drew this graph also. Next is we discussed about what happens when an AC source is connected only across a capacitor. So when you connect it across a capacitor, the value of EMF is going to be E naught sine omega t, and the value of current comes out to be I naught sine omega t plus pi by 2. So there will be a phase difference of pi by 2 that is existing between the EMF and the current, and which one will lead the other? Since current has omega t plus pi by 2, current is going to lead the voltage by pi by 2, and voltage will lag the current by pi by 2. So if at all they use these kind of statements, what kind of a device is this across which is the AC source connected? So if they say current, there is a device, there is a passive element across which there is an AC source connected, and the passive source is in such a way that the current is leading the voltage by pi by 2. If they use this kind of a language, then what is that passive element? It should be a capacitor. Listen to this very carefully. Current leads the voltage by pi by 2. It is capacitor. Okay, because today we are going to discuss another concept there. The reverse scenario will come. So you should be clear about it. Am I clear till this point? So having said this, when you try to draw the phasor diagram, and one more thing, we saw this. I naught is equal to E naught divided by 1 by omega c. What is 1 by omega c called as? It is called as the capacitor reactance, and it is represented by the symbol capital X with a subscript C. Right? So reactance generally comes for materials like capacitors and inductors. If it is a pure resistive circuit, you only call it as resistance. So for resistor, we use the word resistance. For capacitor and inductor, we use the word reactance. We use the word reactance. Reactance is a resistance offered by these devices. Why the name reactance, I'll tell you later. Because there will be some other term that you will be seeing. When I explain a concept called as power factor, at that point I'll explain it. What is the actual significance of it. Till then, you understand this leading and lagging, have it in mind. Am I clear till this point? Now the next question is, when you draw the phasor diagram, if the EMF's vector is stopped at omega t, where should you stop the value of current at? You should stop the current at omega t plus pi by 2. You should stop it at omega t plus pi by 2. And when you draw the graphical representation, so you will take E and I on the x-axis and omega t on the y-axis. So how is the graph going to look like? It will be looking in such a way that EMF is still going to follow the normal sign, but for current, the graph will get shifted to left or right. The graph will get shifted to the left by what angle? By pi by 2. So in this case, one thing will happen. Wherever the EMF is minimum, the current will be maximum. And the vice versa will keep happening. Am I clear till this point? Now, with the same knowledge, right? But before that, I want to tell you one last point that is associated with the capacitor. So please make a note of it. So I told you something called as XC. So what is that XC called as?
Capacitor reactance.
Yes. So XC is equal to, we write it as 1 divided by omega c. But how can I write this omega as? Can I write omega as 2 pi f into c? So omega is equal to 2 pi f. It is either 2 pi by capital T or 2 pi into f. Right? So XC is equal to 1 by 2 pi into fc. Now the question is, if I plot a graph which shows how the value of XC is varying with respect to frequency. Listen to this carefully. If I draw the graph showing the variation of XC with respect to frequency, how will the graph look like? It should be in the downward direction. It will be in a curved path. Any name of that curve? It's called a hyperbola. It's called a rectangular hyperbola. Okay, you draw it in this way. So that is because XC is inversely proportional to F. Am I clear with this? So they can ask you a question, what happens to the value of capacitive reactance when the frequency increases? Answer is capacitive reactance will decrease. See, that is one point to be noted. Am I clear with this? I hope the graph is clear. So what should you take on the y-axis? Xc on the y-axis and frequency on the x-axis. Okay, let me complete it, then you can ask. The second important question is, right, the second important question is, will a capacitor exhibit this property for direct current? Meaning, what would be the capacitive reactance of a capacitor? What would be the reactance of a capacitor when direct current is allowed to flow through it? So for direct current, F will be equal to 0 because there is no change in frequency. Then what will be the value of Xc? It will be infinite. So what does this indicate? Capacitor will not allow direct current to pass through it. So you take a capacitor and connect it across a DC source which has a steady state value. The value of current flowing through the capacitor is 0. But if you recollect, in the second chapter, what is it we dealt with? What is the name of the chapter? Electrostatic potential and capacitance. But if you see all the diagrams that we drew, if you took a capacitor and connected across a DC source like this, then how did we study about the capacitor here alone? If you observe it keenly, right, all the questions will be related to what is the charge stored on the plates of the capacitor. Nowhere they will ask you a question of what is the amount of current flowing through the capacitor, because it doesn't make sense. Whenever you have a capacitor connected across a DC source, this is clearly telling me that the reactance offered by the capacitor is infinite. Means it will not allow the direct current to flow through it. But what will it do rather? When you connect a direct source, what is the job of a capacitor? Can you tell me? The job of a capacitor is not to conduct. The job of a capacitor is to store charge. It is going to hold the charge. That is why nowhere the question will be related to what is the current flowing through the device. They'll ask you what is the charge that is stored on the plates of the capacitor. Am I clear with that point? Are you able to connect the dots? Right? So there are three important things that I discussed. Let me summarize it. What did I say? We know that Xc is equal to 1 by omega c. Right? But omega can be written as 2 pi into f. So when you plot the graph showing the variation of Xc and frequency, how are they both related? They both are inversely proportional to each other in the sense, if frequency increases, Xc should decrease. In what way? In this curved path. What is the name of this curved path? It's called as a rectangular hyperbola. Okay. That is a mathematical term. Nobody will ask you, but just for your knowledge, you can have it in your mind. And from this, one important conclusion that we can draw is, for direct current, the frequency is going to be 0. Right? If it is not a fluctuating direct current, if it is a steady state value, frequency is 0. When frequency is 0, Xc will be infinite. When Xc is infinite, it clearly says capacitor will not allow DC to pass through it. Capacitors will only allow AC to pass through it. Okay. So make a note of it. Directly proportional to straight line. Y is equal to mx is straight line. That chair has a problem. What do you want? Waves la? Electromagnetic waves. Displacement current. அது ஏசின்னு சொல்ல முடியாது. It's a current that is getting induced. It is because of the change in something. Change in some flux value. அது வந்து corrected value of ampere circuit. கண்டக்ஷன் கரண்ட் சொல்லுவாங்க, டிஸ்பிளேஸ்மென்ட் அது வேற இது வேற. ஏசியா டிசியான்னு சொல்ல முடியாது. இட்ஸ் அ கண்டக்ஷன் கரண்ட். இப்போதைக்கு அவ்வளவுதான் வச்சுக்கோ மைண்ட்ல. அது ஏசியா டிசியான்றது unless you know the logic will not be able. புரியுதா? அது எதுக்காக வந்ததுன்னா தட் இஸ் கரெக்ட் மெஷர் டேக்கன் ஃபார் தி ஆம்பியர் சர்க்யூட். அது பண்ணும்போது அந்த டிஸ்பிளேஸ்மென்ட் கரண்ட். Are you done? Okay, so this is one often asked question. Why does a capacitor block direct current and it allows only AC? Okay. So there is a graph. So if you take a capacitor like this, right? This is not my idea. Okay. Direct current will flow like this, no, it will block it. Okay. Don't not my idea. Your meme it. You will find it in Instagram. No? Your meme. It will allow DC to pass through, AC to pass through it. It will go like this. DC means it will directly block. இதெல்லாம் கிரியேட் பண்ணுவாங்கடா. சீரியஸா சொல்றேன். It's there. But there is not the logic. Huh? V is equal to நீ ஒன்று கண்டுபிடிச்சியா? ஒரு மீம் கிரியேட் பண்ணியா? Any? Okay. Okay. Leads. L is for inductor. So current leads the voltage. நீ கண்டுபிடிச்சியா? நீ கண்டுபிடிச்சியா? What he is saying is actually it's a good idea. Because this current leads and lags will come, no? ELI, CE. ELI ஒன்று வச்சுக்கலாம். Okay. And ICE. So whichever is leading, if you remember it like this, current leads the voltage in the case of a capacitor. EMF leads the current in the case of inductor. Daily ஞாபகம் வச்சுக்கணும். ஏதோ ஒன்றா. Okay. Anyways, it is up to you. I'm leaving it to you. However you want to remember. Shall I proceed? Shall we go to inductor? Yeah. So we'll discuss about AC source connected across an inductor. So E is equal to E naught sin omega t is going to be the input again. E is equal to E naught sin omega t. But the question is, we need to find what is the value of current. Right. So how to do this? What is the relation between EMF and inductance? How are they? Like there is a relation. Go to your 6th chapter, right? In the 6th chapter, under self-inductance, there will be a relation that I gave you between E and L. So E is equal to, so you will get E is equal to minus L into di divided by dt. Right. So if you take only the magnitude, what are you going to get? You will get a plus. Okay. Right. So why I took the magnitude here is, listen to this carefully. I discussed a concept called as back EMF. Do you guys remember the back EMF? So what does a back EMF do? When the value of current is increasing, the current in the inductor will be in the opposite direction to the value of, opposite direction to the one which is flowing. So let's say the current is flowing in this direction. The current is flowing in the clockwise direction. Then the back EMF will be in such a way that it will be in the, sorry, the back EMF will induce the current in such a way that it be in the opposite direction, right? Whereas if the current is decreasing, then the induced EMF will support and the current will be in the forward direction. Having said that, right? So what we can actually do is observe. I'll tell you how this equation has actually come. So listen, we know that according to Kirchhoff's law, the sum of the EMFs across all the devices is supposed to be equal to 0. Okay. Now, if you observe, what will happen in this case is E minus, okay, the back EMF will be equal to 0. Why it is 0 is basically, see, had there been a resistive element, you would have written it as I into R, because V is equal to IR according to Ohm's law. But what is happening in this case is there is no resistive element, there is only inductive element that is present. So E minus E back means what? It is a back EMF is equal to 0. So E will be equal to the back EMF. What is going to be the back EMF? That will be L into dI divided by dt. So that is the reason why I wrote E is equal to L into dI by dt. But what should I write in the place of E? I will write E naught sine omega t. So E naught sine omega t is equal to L into di by dt, which implies E naught divided by L into sine omega t dt is equal to di. Can I write it like this? Are you able to understand this? See, this is something called as variables and separable methods. Basically, this is called as a differential equation. I'm just giving you the hint so that you'll be learning about this in your math also. There is the ninth chapter is called as differential equation, and this is an example of one such differential equation. Okay. So why we call it as differential equation is because you have a differential coefficient, derivative of something with respect to something, and it is an equation because you have an equal to sign. So to solve a differential equation, we need to integrate it. So for you to integrate, what you need to do is you need to separate the variables, and this is called as variables separables method. Okay. This is the only way you can solve any differential equation. Now all that you need to do is integrate on both the sides. So when you integrate on both the sides, you will get E naught divided by L into what is the integral of sine omega t? Minus cos omega t divided by omega is equal to, what are you going to get? You will get I. Am I clear till this step? Right? So first make a note till here. புரியல தெரியுமா நான் கொடுத்துருக்கேனா கத்துக்கிட்டியா சரி பரவாயில்ல எழுது Are you done? Yes. So what did you get? You got I is equal to E naught divided by omega L. You have L and omega in the denominator. So E naught divided by omega L into you have minus cos omega t. But the point to be noted here is what is that we started E with? E is equal to E naught sine omega t. So I'll be able to draw the phasor diagram only if both are represented in terms of sine is the first thing. Second thing is both should have the same frequency. So how to make this cos in terms of sine? You observe, this can be written as E naught divided by omega L into minus sine is there, no? Cos omega t can be written as sine of pi by 2 minus omega t, and take the minus sign inside because minus sine theta is sine of minus theta. So when you take it inside, you will get E naught divided by omega L into sine of omega t minus pi by 2. Right, where this omega L is what is called as XL. So this XL is what is called as inductive reactance. Right. So what will happen is this will become E naught divided by omega L into sine of omega t minus pi by 2. This E naught by divided by omega L you can take it as I naught. Right. So this will be I naught times sine of omega t minus pi by 2. And this is going to be the value of I itself. So in this case, what are you going to get? You will get I is equal to I naught times sine of omega t minus pi by 2. Clear with this? Right. So did you understand why we wrote it as sine of pi by 2 minus omega t here? So that the minus sign is pushed inside and minus of minus will become plus. Okay. Now for this, we are going to draw the phasor diagram and the graphical representations. So first copy this, then I'll explain. So let me know once you're done copying. Done? Okay. Shall we see how the phasor diagram is going to be? Yes. So when you draw the phasor diagram, what do you take? You take them to be xy, and here it is going to be x dash and y dash. So first, what will you draw always? You will always draw. You will draw for EMF. So EMF is equal to E naught sine omega t. So if this is O and if this is A, right? What is OA going to be equal to? OA is E naught, right? And where should you stop it at? You'll stop it at omega t. Right. And from omega t, how much will get subtracted for us to write the value of I? So I naught sine of omega t minus pi by 2. See, in the previous case, when we saw the capacitor, to that omega t pi by 2 was getting added. But here from omega t pi by 2 is getting subtracted. See, that is one way of understanding. Or you have omega t at this point. You have omega t here. From omega t, rotate this vector through an angle of 90 degrees, but this time in the clockwise direction because clockwise is negative. Okay, when you rotate it, then you will have the value of current to be this side, so that this angle is pi by 2 and this angle is going to be omega t minus pi by 2. Make sense? And what is going to be the value of OB? OB will be equal to I naught. So this clearly indicates one thing, that EMF is going to lead current by pi by 2, or current is going to lag EMF by pi by 2. So you need to be clear with both. Is the point clear? Right. So first make a note of this. Shall I proceed? Right. Now, after the phasor diagram, what is that we are supposed to see? So we are going to see the graphical representation. Okay, I'll go. Yeah. Don't copy this, okay? Now, when you represent them graphically, what are we going to take the y-axis, EMF and the current, and omega t on the x-axis. So EMF by default is always going to be in this way, right? Whereas when you talk about current, so what is happening to the current? Current is I is equal to I naught sine omega t minus pi by 2. So whenever you have the angle as something minus pi by 2, it will always get shifted to the right. Okay, meaning the value of current will start from here. Sorry. So it keeps going like this. So the meaning of this is, here also when the EMF is maximum, current will be minimum. But the only difference is the graph will start from here. Because what is the logic here? Current is lagging the voltage by pi by 2. So current should be at the bottom and EMF should be at the top. So this is how the graph will be drawn when you connect it. When you connect what? An AC source across a inductor. Right. So what is going to be the equation of this green color graph? Mathematical equation of the green color graph is, yes, the graph of this dotted graph, expression, I is equal to I naught sine of omega t minus. This will be the answer. Clear with this? So you can add these 2 points also. This will be E naught. This will be I naught. Okay. Those are online. Are you able to understand?
Yes, sir.
Yes, sir.
Sure.
Good. Shall I proceed? Right. So we saw one important term here. What is it? I told you something called as inductive reactance. So how is inductive reactance written as? XL is equal to omega into L. So omega can also be written as 2 pi into F into L. So if you take XL on the y-axis and F on the x-axis, how is XL and F related to each other? They both are directly proportional to each other. If I take this to be y, this is of the form y is equal to m into x, where m is actually 2 pi L into x is going to be F. Right. So when you draw the graph, it is going to be a line that is passing through the, it will be a line that is passing through the origin. Makes sense? So when they give you this kind of a graph showing the reactance is varying with respect to frequency in a linear pattern, what is a passive element? It should be an inductor. In this chapter, right, the tricky part is nobody will ask you to directly draw it. The question will always be in the reverse. They'll give you a graph and ask you which element does this, which element will bring this kind of a graph when an AC source is connected across it. So that is how they'll ask you. For example, this there, no, they'll give you this graph and ask you to find out what element it is. It's an inductor. For inductor, so what are the logics you need to know? For inductor, current will lag the voltage by pi by 2. So if current is starting from the negative y-axis, then it should be an inductor. If the current is starting from the positive y-axis, it will be a capacitor. If the current is starting from 0, it will be a resistor. And what they will do is they'll sometimes combine everything and give it in the same graph and ask you what is A, B, and C. They'll ask you these kind of questions. Okay. So make a note of this. With this, we are done with the concept of AC source connected across resistor, capacitor, and inductor. Now we need to see the combinations. Okay. Let me know once you're done with this. You're done? Shall I proceed to the next part? So, see, if you have understood the first three, right, going forward, it is simple for me to take it. Okay. So, only thing you need to have in mind is in which case the EMF and current are in same phase, in which case is EMF leading or lagging the current. These are the points you need to remember. Now, the next topic that we are going to see is about AC circuit with resistance and inductance in series. So you take two passive elements like resistor and inductor, you can either connect them in series or in parallel. Right? Parallel is not in your syllabus. So the only part that you have is when they are connected in series. So let's try to draw the diagram and see. Please move the window away from shared screen. Okay. Yeah. See. Now what we'll have is, we have a resistor and inductor connected in series, and they are still connected across what? The same AC source, which is of the same value E naught sine omega t. That value is fixed throughout the chapter. E is equal to E naught sine omega t. Now, tell me one thing, what will happen when two devices are connected in parallel? Sorry, when two devices are connected in series? The current flowing through both the devices should be the same. Can I say that? So if I say current through the resistor is IR, and I take the current through the inductor is IL, can I say that they both will be in the same direction and at the same pace? Because they are the same thing. Right? Now, we need to come in the reverse. If you see, I use two languages, right? One is I told you which one leads the other, and I also told which one lags the other. So here I'm going to use the reverse language. Okay. So if I take current across the resistor to be in this direction, current across the inductor to also be in the same direction. So I'm writing it as IR itself, because IR is equal to IL because of the series term. I hope I'm clear to this step. Now tell me one thing. When IR is in this direction, what is the relation between the EMF across the resistor and the current across the resistor? They both are in, when you draw the phasor diagram, right? When you draw the phasor diagram, how did you draw the EMF and current to exist for an AC source connected across the resistor? They both were in same phase. Meaning, if the current across the resistor is in this direction, the voltage across the resistor would also have been in the same direction. Make sense? So basically, what is this EMF is getting divided into two parts. What is it? The EMF across the resistor and the EMF across the inductor. Listen to this carefully so that you will understand it. Right. Now, what I'm going to do is, if the current across the inductor is taken to be in this direction, IR and IL are in the same direction. Now, what is the relation between the current and the voltage in the case of an inductor? In the case of an inductor, current lags the voltage by pi by 2. So, who's leading? Voltage is leading the current by pi by 2. Meaning, if current is in this direction, voltage should be 90 degrees before it. Meaning, if IR is like this, VL should have been like this. Makes sense? Did you understand what I do? Now, all that I'm concerned about is, I'm concerned about how or what is the relation between VR and VL and what is the phase difference between them. So if VR is taken to be horizontal and VL is taken to be vertical, what is the angle between both? Angle between both is 90 degrees, right? So what I'm going to do is, I'll combine and draw, right? I'm going to combine and draw a phasor diagram. Here I'm not going to represent anything graphically because you cannot draw it. You don't know what is the relation between current and voltage. All that you know is, you know what is the angle between the voltage across the resistor and the voltage across the inductor. So if I take VR to be in this direction, wait. If I take VR to be in this direction, right? In which direction will VL be? See, if VR is like this and VL is upwards, okay. See, VR is like this, VL is upward, right? Like this. If I rotate VR like this, then VL should also get rotated in such a way that the angle between them is always going to be 90 degrees. So, anti-clockwise, I need to rotate it through an angle 90 degrees so that this will be VL. Am I clear to this point? Did you understand why I do it like this? Because I took the reference from here. I told you I'm not concerned about IR because it's series connection. I'm only concerned about what is the relation between VR and VL. Am I clear? Right? So first make a note till this point. LCR ஆரம்பிச்சிருக்கலாமா? இது புரிஞ்சாத LCR வரும். எப்படி ஆகும் சீரோ? That's not how you learn. Because each circuit has a reference. இது ஒரு இடத்துல கொஸ்டின் கேட்பாங்க. Where do you use this choke coil ஒன்று வரும். அது எப்படி சொல்லுவேன் LCR வச்சுட்டு? LCR has a completely different application. It's not about low resistance. RL circuit, RL L connected in series is used in a choke coil. அதுக்கு LCR example யூஸ் பண்ண முடியாது. LCR is used in tuner circuits. ஒன்னொன்னா தானே போக முடியும். இது ரெண்டு கம்பைன் பண்ணது அங்க வரும். It's not like you take C to B0, R to B0 அப்படி எடுத்து. That's not the way you learn. இதை கம்பைன் பண்ணிட்டு தான் அங்க பண்ணணும். ஏன் அப்படி வருது LCR? அதுதான் பண்ண போறேன். இன்னும் முடிக்கல. I asked you to copy till this step so that you go in your mind. First இது வரைக்கும் இன்னும் முடியல. Okay. Am I cleared up? Shall I proceed? Yes. Now, VR, can I write it as equal to I into R, where I is nothing but the current across resistor and the current across the inductor. So I'll just give you a note here. IR is equal to IL is equal to I itself. Okay, can I write VR is equal to I into R? Then what can I write VL as? It will be I into XL. Right. So VL will be equal to I into XL. Are you convinced with this? Right. Now the question is, this is a vector and this is a vector. Right. So how will the resultant be? When there are two vectors, the resultant is going to be in this direction. And for the resultant, I will represent it as V with the subscript Z. Okay. And VZ is written as I into Z. Any idea what that Z is called as? What is it? What is that Z called as? Why are you using that term? When will you use impedance? It's not about two. Whenever you have a combination of resistance and a reactive element, whenever you have a combination of resistive and reactive element, the equivalent resistance is what is called as impedance. Okay. So, having said this, what will be the value of Vz? Vz will be equal to, now apply the parallelogram law of vectors. What is it? Vz is equal to root of Vr square plus Vl square plus 2 times Vr into Vl into cos of how much? What is the angle between them? The angle between them is 90. So it should be cos pi by 2. So this will be a 0. So Vz will be equal to how much? Vz will be equal to root of IR the whole square plus I into XL the whole square. Right. So what will you take out? You take out I outside. I into root of R square plus XL square will come out to be Vz. But what is Vz? I've already written Vz. It is I into Z. So what will get cancelled? I and I will get cancelled. Z will be equal to root of R square plus XL square. Right? And what is this term Z called as? Z is called as the impedance. Okay, impedance is like the equivalent resistance that is formed due to the combination of resistive and reactive elements. Okay, because when you take two elements, right, in permutation and combination, what are the combinations that are possible? You can think of resistor, inductor. You can think of resistor, capacitor, and the third you can think of capacitor and inductor. So for capacitor, inductor, we don't define something called as impedance at all, because it has a completely different operation. We call it as an oscillator circuit. I'll teach you, but I'm saying there you can't use the word of impedance. So impedance epo varum. Impedance is used only when you have at least one of the elements to be a resistor. Right? So Z will be equal to root of R square plus XL square. Okay. Now listen to one last point with respect to this derivation. That is, if you observe the Vz value, right, the Vz vector is making an angle phi with respect to Vr. Right, what is happening? Vz is making an angle of phi with respect to Vr. Now, according to the parallelogram law of vectors, if I write tan phi, what will I get? So tan phi will be equal to opposite divided by adjacent. So it will be VL divided by VR. But what is the value of VL? It is I into XL. And what is the value of VR? So I and I will get cancelled. It will be XL divided by R. So tan phi will be equal to XL divided by R. Means here you're saying that the resultant is making an angle of tan inverse of XL divided by R with respect to VR. Because had you taken phi value here, it would have been something else. So this is that phase difference. So what I'm trying to say is, if you write E is equal to E naught sine omega t, here the value of I will be equal to I naught sine of omega t plus phi. Okay, and that phi value is, what is this? Tan inverse of XL by R. Are you able to understand? So this is how it works. Right? See, from this we can actually derive another value called as cos phi. Okay, that cos phi has a significance. What is it? Why do we call it as power factor? We'll see it later. So tan phi is equal to XL divided by R. You can find cos phi also using the basics of trigonometry. You can derive it. You will get R by Z. Okay. So if you take it, you will get R divided by Z. That is called as power factor. But as of now, you don't need to worry about that. Okay. I'll tell you at that point after I complete the derivation for power. Okay. So is it clear? So this is all about AC circuit connected across a resistor inductor in series. The next topic that we are supposed to discuss is resistance AC circuit connected across resistor and capacitor in series. And the third part will be resistor, capacitor and inductor in series. That is the most important one, which is called as LCR. From there we'll learn something called as resonance. Have you heard all these terms? We have seen resonance. So what that resonance signifies and everything, I'll discuss it later. Is the point clear? Right. So any other questions? Right. So you can revise it till here and come. The next class I'll start with AC circuit across resistor and capacitor. Okay. So if there are any questions or see, actually we have dropped the Google form in the group. If you see, did you all observe? Okay, you guys at least saw. So the Google form is mainly to understand if you need help with any other topics that I have not completed. Okay. Because most of you are saying that you have exams and everything, right? So if there are any topics with which you need help with, so I cannot do everything. That also I tell you. I cannot teach every topic and put it. But for whichever topic you need help with, I can actually record and give it to you. So the time will get saved. Okay, you fill that Google form, go and see. Okay. That's it. Okay, those are online. Are you clear?
Sir.
Sir.
Yes, sir.
Okay. Then we'll wind up.
Thank you, sir.
Yeah. Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.